Take attendance real quick. And then we're going to start our notes. We are going to need our calculators, but not right away. We're going to do some no calculator stuff first. You will need your green sheet. If you don't have one, you'll have to use your neighbors, and then you'll print one from Canvas. Green one from Canvas. It won't be green, but that doesn't matter. All right? So we're going to need that today. I am on notes page 4, section 4.2. There is a triangle drawn. Directions say find the value of all 6 trig functions. This is on your sheet. Hopefully you are getting comfortable with it because there's a lot. But anybody you ask, anybody who has studied trigonometry will tell you that it is very, very easy if you've done the memorization. There is some memorization you just have to do. All right? But if you do that, then the concepts are really, really easy. So here's the deal. We got a triangle up here. We have an angle. Anybody remember what do we call that? What letter is that? Theta. That's theta. Right? That's our angle. And we are going to find the sine, cosine, tangent, cosecant, secant, and cotangent. Those words are on your green sheet. We never write cosecant. We use the abbreviation CSC. That's cosecant. Now, I have lined these up for you in a very specific order. Sine and cosecant are reciprocals. So you know what that means. If the sine, these are all fractions. So if the sine is 2/3, then the cosecant would be 3/2. So I have lined them up in their reciprocal pairs. Now, I won't always do that. This is day 1, we're just beginning, so I set it up so it would be easiest for you. But again, you are responsible for memorizing that sine and cosecant are reciprocals of each other. Cosine and secant are reciprocals of each other. And tangent, that's not right. Tangent and cotangent are reciprocals of each other. Remember that when you're talking about the reciprocals, no cos go together. No cos go together. So you have regular sine and cosecant. You have cosine and regular secant. See what I mean? Never pair up the cos. All right, so how does this work? Well, you've got the definitions on your sheet. What we need to establish first is which side is which in this right triangle. In a right triangle, the longest side is called the hypotenuse. So this is your hypotenuse, always. Since my angle is here, this side over here, look where I'm going, this side over here, across the triangle, is called the opposite side. The side that you call opposite is the one that is across from the angle. There's my angle. This is the opposite side. If that had been my angle, this would be the opposite side. The opposite side changes depending on the angle. This side is called the adjacent side. What does adjacent mean?
Next to.
Next to. That side is right next to the angle. It's called the adjacent side. Now, if you look at your green sheet, you see what sine is. What is sine? Sine is opposite over hypotenuse. So opposite over hypotenuse would be 2 over root 13, which automatically means the cosecant is what? Root 13 over 2. Cosine. Definition. Adjacent over hypotenuse, which means 3 over root 13. So the secant is root 13 over 3. What is tangent? Opposite over adjacent. So that would be 2/3, which means your cotangent is 3/2. Perfect. Now, to help you remember those definitions, there is a little mnemonic device that you've probably heard before. SOHCAHTOA, have you ever heard that? Chief SOHCAHTOA is the chief of the trigonometry tribe. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. And tangent, opposite over adjacent. Let's try the next one. Pay attention to where your angle is. All right, here we go. Label those sides. Which one's the hypotenuse? 13. Now look where your angle is. Which one's opposite? Yeah, 5 is the opposite side this time. The opposite side moves around depending on the angle. So this side is the adjacent. All right, see if you can fill them in. SOHCAHTOA, use your green sheet. SOHCAHTOA. See if you can fill in those values. Five over 13, which automatically means the cosecant is 13 over 5. Cosine, 12 over 13, which means secant is 13/12. Tangent, 5/12. So cotangent is 12/5. Easy, right? Gotta remember what sine, cosine, and tangent are. But if you remember that, you have a maiden shape. Remember, you won't always have your green sheet. We're working our way up. Do not need it. Okay, let's look at the next one, C. What's a little different about problem C?
They don't give you the hypotenuse.
They don't give me the hypotenuse. Oh, shoot. What am I gonna do? I need the hypotenuse, obviously. What am I gonna do? How do I find it? You know this. Starts with a P. One of the most famous theorems in all of geometry. The Pythagorean theorem. And what does the Pythagorean theorem say? Right now, whoever you had for geometry is breaking out in a rash. What is the Pythagorean theorem? A squared plus B squared equals C squared. Now listen, the important thing to remember here is C is the hypotenuse. Nobody cares what A and B are. It doesn't matter. A and B are something, but C must be the hypotenuse. So in this triangle, isn't that what I'm trying to find? So 1 squared plus 3 squared equals C squared. So 1 plus 9 is C squared.
Yeah.
10 is C squared. So C is the square root of 10. Did you follow all those steps, my friends? Yep.
Yep.
So I know my hypotenuse is the square root of 10. Now look at your angle. What's opposite? 3. And this guy must be adjacent. Okay, now we fill them in. So sine is?
3 over 1.
What? What's sine? So,
3 over
3 over root 10. Opposite over hypotenuse. Cosecant then is root 10 over 3. What's the cosine?
1 over 10.
Root 10. 1 over root 10. Adjacent over hypotenuse. So secant is root 10 over 1. And let's just agree that we're not going to write root 10 over 1. We're just going to write plain old root 10. And then tangent, 3 over 1, 3, which means cotangent is 1/3, 1 over 3. All right, one more of these. This is another one where we don't have something. This time though, we do have, this is problem D, this time we do have the hypotenuse, right? So we are missing one of the other sides, either A or B, and it doesn't matter, I'm just gonna call it A, doesn't matter. Call it whatever you want. What does the Pythagorean theorem say then? A squared plus 2 squared equals 5 squared? It is really, really important that you remember the hypotenuse is by itself. So A squared plus 4 equals 25. So A squared equals 21. So what is A gonna be? Square root of 21. Okay, we need to be able to do that. We all good? All right, this is obviously the hypotenuse. Which one's opposite? Root 21. And then this guy's adjacent. I would recommend you always label those, just so, I just think it's easier if they're labeled. All right, fill them in, let's see what you come up with. Anybody got them? What'd you say for sine? Square root of 21 over 5? Cosecant 5 over square root of 21. Perfect. Alright, who's got a cosine for us? 2/5. So the secant is 5/2. And then how about a tangent? Root 21 over 2. So 2 over the square root of 21. How does that look to everybody? Got it? Alright. Next problem. I didn't mark the theta in that triangle, but go ahead and put theta right there. When a triangle isn't already drawn for you, I want you to set it up like this, alright? So draw your coordinate axis system, draw a little triangle right here in quadrant 1, and that will be theta at the origin there. Alright, your life is going to be easier if you just draw your triangles that way. Now, if they draw one for you, then you got to go with it. But if no triangle is drawn and labeled for you, draw it this way. Okay? Now, they gave me nothing about these sides. All they told me was that the sine is 2/3. Now, that automatically means the cosecant is 3/2. I got that. Now what? Exactly. What is the definition of sine? Opposite over hypotenuse. So aren't they telling me that the opposite side is 2 and the hypotenuse is 3? Okay, so here's my hypotenuse. Where's my opposite side? Here? Here's your angle, remember? Here. So there is your triangle. Now you're still missing a side, but that's okay. We'll use our Pythagorean theorem, so go ahead and do that. See if you can do that without me. And you find the missing side of the triangle. Hint, if you say square root of 13, you are wrong. You're doing it wrong. If you say square root of 13, what is it? Square root of 5. Make sure you're getting the square root of 5. Remember, a squared plus b squared equals c squared. That's c. All good?
Yep.
All right, friends, fill them in. We already have the sign, that's already done, but go ahead and fill in the rest of them. All right, I filled mine in. How do yours compare to mine? Good? Everybody on board? All right. Another one just like it. This time, the only thing they told me was that the cotangent is 1/4. Okay? If the cotangent is 1/4, then doesn't the tangent have to be 4 over 1?
Yep.
4? All right, so tell me what I know about tangent. Tangent, so good, TOA. Tangent is opposite over adjacent.
Yeah.
So here's my picture, my standard picture. Opposite is 4, adjacent is 1. So now what are y'all doing? I'll tell you what you should be doing. You should be doing your Pythagorean theorem. Because you're missing a side. Kyle says he thinks it's root 17. What do the rest of you think?
Yep.
Root 17? All right, let's fill them in. Sine would be 4 over root 17. So cosecant is root 17 over 4. Cosine is 1 over root 17. So the secant is root 17. Problem D, this was a mistake on my part. Problem D is exactly the same. So we're not going to be doing D. You can do it on your own if you want. The answers are right here. It's this right here. But we are going to do C. In fact, you're going to do C right now with your partner without me. Notice there's no picture at all drawn. So you're going to draw your own picture. And how are you going to draw it? You're going to draw it exactly the way I asked you to. You're going to set up a coordinate axis. You're going to draw a triangle right there in quadrant 1, just like that. That is how you're going to draw your triangles. Right, so go. Help each other if you get stuck. All right, boys and girls, I hope you put a root 5 here and a 3 here. Why? Cosine is adjacent over hypotenuse. So I'll call that A, it doesn't matter, call it whatever you want. A squared plus root 5 squared equals 3 squared. What's root 5 squared? 5. So A squared equals 4, and A this time works out to be 2. So if you got something else, check your work. Check your work. D is just like D. All right, so your sine is 2/3 and your cosecant is 3/2. Your tangent is 2 over root 5 and your cotangent is root 5 over 2. How do we feel about that? Good?
Yeah, great.
Great. Okay, now we're gonna step it up a notch. Part 3, evaluate without a calculator the sign of pi over 6. Now, the first thing I want you to do is tell me, what is pi over 6? Think about yesterday. Pi over 6, 180 over 6, which is 30. 18 divided by 6 is 3, so 30. So this is 30 degrees. You are going to find the sine of 30 degrees without a calculator, okay? Anytime the problem uses the word exact, that means no calculator. Because when you type stuff in on your calculator, you get big ugly decimals that you have to round off, and then it's not exact anymore. So exact means by hand. So I am going to draw the same picture I've encouraged you to draw all along, but this time, instead of putting a theta here, I'm going to put my 30 there. Theta is your angle, and in these problems I didn't know what it was, so I called it theta. Now I know exactly what it is. It's 30. Okay? Now, in geometry class years ago, you learned about what we call the special triangles. 30, 60, 90. Does that ring a bell? You may not remember anything about it. 30, 60, 90. That's what we got right here. You recognize that? We have a 30 and a 90, and there's a 60 right there. Okay? In every 30, 60, 90 triangle, the sides are the same. Okay? They're in the same ratio. Across from the 30, across from the 30 is 1. The hypotenuse is 2, and the 60, or the other side, is root 3. Those numbers never change. And if you look at your green sheet down at the bottom, on the sheet that says memorize, I got it down there. That will never change. If your triangle is 30, 60, 90, the 30 gets a 1, the 90 gets a 2, and the other one's root 3. Okay? Now, wait a second. Wouldn't this be the opposite side? And the adjacent side and the hypotenuse, if that's my angle? And I want the sine. What do I know about sine? Sine is opposite over hypotenuse. So the answer is 1/2. 1/2. Okay. Tangent pi over 4. What is the first thing you're going to do? 180 divided by 4. Remember, you will have a baby calculator to help you with that arithmetic. But you'll probably have memorized by the time you get to the quiz or something. 180 divided by 4 is 45. So back when you were younger, you had the 30, 60, 90 triangles, and then you had, what was the other one you had? 35, 45, 90 triangles. So I'm going to draw my picture. Same picture I always draw. My angle, which always goes right here at the origin, is 45. Now, what do we know about the sides of a 45, 45, 90? 1, 1, root 2. And again, that never changes. There are two triangles you have to memorize, the 30, 60, 90, and the 45, 45, 90. You're gonna get so sick of those numbers, because those are my numbers to use. Root 3, 2, 1, root 2, you know, those, that's it. All right, we want the tangent. So, this is my hypotenuse, this is my opposite, this is my adjacent, here's my angle. What is tangent? So, Katoa, opposite over adjacent, so the tangent is 1/1, which is you see what I meant when I said it was easy if you have everything memorized? There's a lot to know, but it's easy. All right, secant pi over 3. What is the first thing you're going to do? 180 over 3, which is 60. So we're going to do secant 60. Then you're going to draw your picture, the same picture we draw every time. Your angle always goes at the origin, so it's always going to go right there. This is another 30, 60, 90. Remember that across from this is where the 30 would be, right? So across from the 30 is 1. The hypotenuse is 2. And the other side is root 3. Somehow you gotta remember that, you guys. You gotta remember that. Okay, this is hypotenuse, opposite, adjacent. I want secant. Now, I don't really remember what's true. Honestly, I don't really remember what secant is, but I know it's the reciprocal of the cosine. So Katoa. So cosine is adjacent over hypotenuse. So secant is going to be hypotenuse over adjacent. So 2/1 or 2. Are you ready to try one on your own?
Yep.
Let's give D a shot. Find the cotangent of pi over 6. What was your degree measure? Pi over 6 is 30. And you put your 30 right here. Across from the 30 is 1. Hypotenuse is 2. Other side is 3. You wanted the cotangent. Cotangent is, let's see, tangent is TOA. So cotangent would be adjacent over opposite. So adjacent, here's my picture, adjacent over opposite. Did you get root 3? All right, 2 more. You and your partner working out. I'm not going to write it down. I'm just going to listen to your answers. You're just going to tell me what the answers are. Or we're looking at E and F. I will walk around and you can ask me if you have a question. All right, here we go. Show me. I want you to show me. All right, anybody get an answer to E that you think is right? What was your hand up for? I was so excited. All right, Joseph. Square root of 2. You should have gotten square root of 2 for problem E. Yeah.
Hey, we got
Square root of 2. You guys get it?
Yeah. Great. Yes, sir. Thank you.
All right, who's got an answer to F that you think is right?
get
Right?
We get that one.
Square root of 3 over 2. Ronick says F is the square root of 3 over 2.
That's wrong.
I don't think that's right.
That's right.
Let's check. Quiet, guys, quiet. We're checking F. We're finding the cosine of 60.
Yes.
In that triangle, would you agree that the 30 is up here?
Yeah.
So that's the 1.
Yeah.
This is the 2, and this is the root 3. I want cosine, which is adjacent over hypotenuse. How many of you got 1/2 for that one? 1/2.
Oh, this is that. Right now, it's gotta be on.
You got one? Was a 45-degree angle, and your triangle looked like that? You wanted cosine. Since hypotenuse are opposite, that's how we got root 2. All right. A little out of control here. Everybody good? Figure out what you did wrong if you made a mistake. All right. Get your calculators out. What did Mrs. Ford tell you about a calculator? Gotta have it every day. Gotta have it every day. Not gonna use it for everything, but we gotta have it. I have a great idea. Maybe those that don't bring their calculator, I'll take their phone. And I'll keep your phone until you bring the calculator.
That's a good idea. That's a great idea.
That would wake you up, wouldn't it?
Yeah.
Yeah. Bring your calculators. All right. And they got to charge. No such bringing the dead calculator. All right. Look at problem 4. Look at problem 4. Problem 4. Some of the angles are in degrees. They have a degree mark. And some of them don't have a degree mark, which means they are in radians. So right now, we are going to circle all the ones that have degrees. So A is a degree,
C.
C, E, calculator needs to know whether what you're inputting is a degree or a radian. And if we don't do all the degrees first, we're gonna have to be switching back and forth, and I don't wanna do that. So I'm gonna do all the degree problems first. Then I'll show you how to change your calculator, and we'll do all of the radian problems. Okay? So first thing we gotta do is make sure we're in degree mode. So let's turn on our calculator and press the mode button. Mode, right here where I'm pointing, mode. It says mode. And then you want to make sure that degree is highlighted. So if it's not, click over to it and press enter. And now degree is highlighted. Okay? All right. Now, problem A. Listen, you guys, if you're talking, you're not going to get this, and then I'm going to get really mad. Because I don't want to repeat myself. Problem A says I need a secant. Crap. Do I have a secant button? No, I do not. I have 3 trig buttons, sine, cosine, and tangent. That's all I've got. So, in order to type a secant, I have to remember what a secant is. Who remembers? It's the reciprocal of the cosine. So type 1 divided by cosine 10. Secant is 1 over the cosine. Reciprocal, 1 over. So 1 divided by cosine 10, and you should have gotten 1.0154. Nope. 1 divided by cosine 10. You have to be in degree mode or you aren't going to get the right answer. So remember, we went to mode, changed it to degrees, and now we got it. Yes. I like degree and press enter. All right. Now I'm ready for problem B. Do I have a tangent?
Yes.
Is the radian highlighted? I need to highlight it. No. Isn't that what I did? 1 divided by cosine 10. You have to hit enter after you. I don't know. I just did it. Okay. Do I have a tangent button?
Yep.
Yes. So I'm going to press it. Now, do you remember from yesterday how to put in 28 degrees, 11 minutes?
Okay.
28 second apps degree, 11 second apps minute. And you should have gotten 0.5358. Now we are skipping C for the time being. No, we did B.
East Coast side. I think it's that you only do
Here are my notes. Yeah, we skipped it down to C. Yeah. All right, we skipped it. All right. So now I'm going down to E. Do I have a cotangent button? No. When I don't have the button, I have to do 1 over. And since it's cotangent, I'll do 1 over tangent. So 1 divided by tangent. And then 13 second angle degrees, and 19 second angle minutes. 4.2248. All right, F. Do I have a sign button? Hit press it. No one over, just straight up sign. 127 second angle degree. 18 second angle minute. And then 13, how do I get my seconds to the numbers? Alpha plus. 0.7954. Now I'm skipping down to I, because I'm doing all the degree problems first. Do I have a cotangent button? No. So how do I handle it? 1 divided by tangent. 158 degrees, 19. Negative 2.5150. We haven't yet, but you can get negatives. No big deal, they just come out negative, that's okay. And then finally J, that's an easy one. Tangent, 300 degrees, 18. Another negative, negative 1.7113. That look okay to everybody? All right, you know why you don't. All right, now, in order to do the rest of the problems, I have to change my calculator into radians. So I go back to mode, and I highlight radians, and then I'm ready to do problem B. All right, we're almost out of time, let's get B done. So is your calculator radians? All right, so we're going to press cosine. I have a cosine button. And then I have to do pi divided by 9. So I find my pi button, which is right under the clear. So second pi divided by 9. You literally type the angle that's written there. It's pi over 9. So cosine pi over 9, you should have gotten 0.9397. 0.9397. We will finish the rest of those guys tomorrow, or you can probably finish them on your own. Let's remember that 4.1 is due tomorrow.